Hi guys, welcome back to a new IMONST video. So in this series we will be talking about IMONST 2, which is the test that you get selected into after you've get a good result on IMONST 1. So it is necessary to do well on IMONST 1, at best 50 out of 50, right? When you get into IMONST 2, because in IMONST 2 the problems are much harder than as compared to IMONST 1 because they consist of essay problems, proof type problems, and if this is the first time you're watching this, it's okay. Let me guide you along step by step. Now, because these videos might take a much longer time, so I'm gonna make just one question per video. Now let's look at problem 1, and this is the only problem for this video, and problem 2 for one video, problem 3 one video, and so on and so forth. Now, for IMONST 2020 Junior, a right triangle has sides of lengths A, B, and C, C being the length of the hypotenuse. Inside the triangle, we place a circle such that it touches all three sides of the triangle. Now, let's prove that the radius of this circle is equal to, where is my pen? A plus B minus C divided by 2. So this is what we want to find. Now, since this is a right triangle meaning one of its angles is 90 degrees. Okay, I won't go into much detail, but I'll just kind of draw one of these out here. Then we have a circle right here. Yeah, something like this. Then we have our second point over here. Let me see. Okay, this might take like a minute or two, so you guys kind of bear with it for a while because I need to make a good picture so that it facilitates our like solving process, you know. So something like this. This is like a rough estimate, but anyways. Okay, one last thing. We lengthen this. Then this one also. Voila. This might not be the best circle, but this is good enough to make an explanation. Now, since this circle touches at these points, let's call these D, E, and F. And then C is this. This is C. Then B and A, you can swap your positions, it doesn't matter. Then so normally normally we would write big A as the vertex opposite to this line A, and then big B opposite to this line B, and then big C opposite to this line C. Okay, this, I don't care about uppercase, smaller case. What's important is the E and F. Okay, so I need to introduce two facts about the circle theorem. So if we have a circle, I need to draw two circles because I'm introducing two facts. So one circle and two circles. So these are the fundamentals that you need to know when solving this problem in particular. So fact 1 is that if you have a circle over here, and then you have a tangent line going through over here, then from the circle's center to the point of tangency, which is there's only one point, okay, this would be 90 degrees. Okay, so this is one fact that you guys need to know if you do not know. Then the second fact would be, if we have a circle over here, and then we have a point outside here, and then we want to draw two lines of tangency to this circle, something like this. This is not accurate, but try to understand it at best. Okay, I apologize for my kind of like horrible drawing, but anyways. Okay, as you can see here, this is a close one, so I'm just gonna, so this one and this one. So let's call these points A, B, and C, not to be confused with the original A, B, and C. Then the circle center be O. Okay, since from the above fact, we know that angle ABO is 90 degrees, and angle ACO is also 90 degrees. Okay, and then we know that these two lines are the radius, so they are of the same length. And then this one is a shared line, so both of these of course have the same length. So due to this, so we have this one, and this one, we would have triangle ABO being congruent to triangle ACO. So what is the reason? It's because of the angle 90 degrees, the S, a side, which is the radius, and then another side, which is the common length AO. Okay, so from here we know that AB is equal to AC. Okay, so using this fact is very important later, we can apply it over here, right? So let us make up some, I don't know, variables. Okay, so we can, so since this is like a proof type question, we need to write it in like some essay form. So let D, E, F be the points of tangency on, okay, DF being on B, then we have E on C, A respectively. Okay, does not matter. You can change the position of DF. It's not important. Okay, so points of tangency on B, C, A respectively, and then from the circle theorem, there's a lot of things in the circle theorem, to be honest. Also, I'm not really sure if this is the correct name, but anyways, from the circle theorem, we know that AD equals to AE. So we can set this as some x, right? So we have an x here, we have an x here, right? And then we would have BE equals to BF equals to some y here, okay? And then we would have CD equals to CF equals to some z over here. Now, since this is a right triangle, this one would be 90 degrees. So, okay. Also, let the center of circle be O. Now, this is of course introductory, but as you do more of these types of problems, in these kinds of cases, the O is not necessary of. It's like a convention, okay? Like we use this conveniently, okay? Now, we can see that from our first circle theorem fact. So this one. So this is 90 degrees. Okay, so we would have CD equals to OF, and then we would have CF equals to OD. And then since CD equals to CF itself, this would mean that CDOF is a square, okay? CDOF is a square. And OD, the radius, is of length Z. Now, we know that using our previous notation, as we can see here, so we have ABC, right, but we split them up into some x's, y's, and z's. So using our previous notation, since we let A equals to y plus z, then we would have B equals to x plus z, then C equals to x plus y. So since we have our radius being z, right? Okay, so the circle's radius z is equal to, now this is a long one. I know this is I know it's not in a very paragraph-like form, but I'm trying my best. Okay, sorry. Okay, the circle's radius z is equal to 2z over 2. Now, how do we get a 2z? We could get a x plus z plus y plus z minus x plus y divided by 2. So in Chinese, we would call this 无中生有, meaning you create something out of nothing, right? This is quite a powerful tool Okay, because the x's and y's cancel out each other, right? So we would have this one. So x plus z is b plus a, y plus z, and then minus c divided by 2, which is, I know, it is already equal to a plus b minus c divided by 2. So since we have done this question, we would put a QED at the end of the question, or you could put like a black box, meaning that you have demonstrated which is what to be demonstrated. Okay, so I hope that you guys have had little difficulties understanding my problem solving process. Of course, since I wanted to adapt for beginners, so this one would be how do I say? I would take a bit more time to explain some stuff, but maybe if some people already know this kind of stuff, you could skip certain parts, of course. Now, so this is the problem for this video. In the next video, we'll be talking about IMONST 2 2020 Junior, problem 2. So, see you there.